Alright, welcome back to another video. In today's video we're going to be going a little bit deeper into the features of classes. Okay, if you don't know too much about classes right now, I would strongly recommend that you look at my previous video. I'll link it in the description. I just sort of briefly touched on what classes actually are, the concept of classes, and a bit of basic information for how you implement them in Python. Okay, so you will need a little bit of basic knowledge about how classes actually work first before watching this video. Anyway, if you do know about classes and you want to know a little bit more, continue watching. Let's get into it. So I'm going to be looking at three main features of classes in this video. They are encapsulation, inheritance, and polymorphism. Let's start off with encapsulation. So encapsulation is basically where you are making use of what are known as private and public attributes. It's where you consider a class as a sort of single unit, and you can access different information about the class and about the object through using getters and setters. Okay, I looked at this in my last video. Where I talked about, in the dog example, I talked about how the dog's favorite food, I made that a private attribute. This is encapsulation. So let's go into an example of how you can use encapsulation in Python now. Alright, here is a simple class that I've made. It's another dog class. Now I have shown an example of a public attribute and a private attribute. Okay, so this here is a public attribute. Public attributes can be accessed from within the class and outside of the class. That means that they can, in certain circumstances, actually be unintentionally edited or intentionally edited from outside the class. So they're not protected in any way. So if I tried, for example, going outside of the class, let me create an object first. My dog equals dog. I'll call him Jimmy, and he is a Labrador. Okay. Let's say I wanted to print out his name, for example. That would be very easy. Print self.name. Not self.name, sorry. My dog.name. See, this is possible because it's a public attribute, so it's not protected in any way. It can be directly accessed. Okay, let's give this a try. As you can see, we can print it out. Now, if we try the same thing for this private attribute here, I'll say private. You can't actually have private attributes in Python. I'll go into that in a second, but let me try this. Now I'm going to try this private attribute indicated by these two underscores here. As you can see, it's not possible. It can't actually find this attribute. Okay? Now, I said that the private attributes in Python aren't actually private. And the reason for this is because Python doesn't have private attributes, but rather when you add these double underscores, this attribute undergoes a process called name mangling. Okay? And what name mangling does is it changes the way that Python stores the identifier of this variable. See, the identifier of this variable is name, right? This is just going to be stored as name in Python. Whereas this attribute, double underscore favorite food, is not going to be stored like this, but rather it will be stored using the name of the class sort of appended to the front. Okay, so the way that this private attribute, I'll say private like this, the way that this private attribute will be stored will be something like this. It would go underscore and then the name of the class, dog, and then double underscore fav food. This is its name mangled name, right? And what this does, while it's not private, because if someone knows what this name is, if someone knows this identified, they can still access it. Whereas what this does, it does avoid any sort of unintentional editing of an attribute like this. Okay? Because if someone was to know that the favorite food was stored under this fav food variable name, they wouldn't be able to edit it because it's been name mangled. Okay? So how do you actually access these? Well, I touched on this in the last video, but you have to use getters and setters. So let's create a getter for this. A getter is just, or a get method, also known as. The way you do it, just say get fav food, something like this. And then all it does, it just returns this attribute. And since this is a private attribute, it can be accessed from anywhere within the class, okay, including any of these methods. But the thing about this method, right, is it's a private method, okay? So methods can also undergo name mangling if you want, but this is a public method. What that means is it can be accessed also from outside the class, allowing you to get the value of this private attribute. But the good thing about having a getter and a setter is that it allows you to undergo some sort of criteria or validation before you return that name or before you change a value. Okay, I'll show that in this set method here. Okay, so if we have this set method, set fav food, what we can do here is we can undergo some sort of check before it changes the value of this attribute. So here we'd have to say new food, okay, and you could type if new food equals, I think the last video I said chips, right? Then you would say print this is not a suitable food. Okay, so if the user enters chips to try and change the value of this to chips, it wouldn't be possible. Okay, say else, and then we say self dot fav food equals new food, just like that. And now if I try and access the fav food, I can say print my dog dot get fav food, just like that, and it should print out the value of this attribute. There we go, beef. Perfect. So now let's try setting it to chips, see if our validation works. We're going to do my dog dot set favorite food, and we're going to set it as chips, see if it works. There we go. As you can see, it says this is not a suitable food. Perfect. Alright, so the next feature of classes we're going to look at is inheritance. Inheritance is kind of what it sounds like, right? If you have what's known as a parent class is the sort of, it's the class which child classes can inherit from. Okay, so you can create another class based on the methods and attributes from a previous class. Okay, so for example, if you have the dog class to start off with, then you try and create another class, let's say a more specific or like specialized type of class. For example, a Labrador class. A Labrador is a type of dog, right? So a lot of the features of dog will be similar in the Labrador class. Okay, so the Labrador class, instead of having to build everything from scratch, the Labrador class can inherit some of the methods and attributes from the dog class and then create this new class with some slightly different features. For example, some different methods. Okay, so let's see how this is done in Python. Alright, so I've pulled up that same dog class again. Okay, so this is going to be our parent class. Okay, so there are different names for the same kind of thing, right? You can have parent class or super class, it's also called as. And then the classes which inherit from this class are sometimes called child classes or subclasses or derived classes even. Okay, so this is going to be our parent class. It has all the similar sort of methods. It has this init function which gets its name and breed and also gets its favorite food to start off with. But in our Labrador, we might want to have some slightly different stuff, like it might have to bark differently, for example. It might have a different bark from the initial dog, okay? And it might also be able to choose from different favorite foods. So we can make that happen here, okay? So let's create a Labrador class now, okay? So the Labrador starts like this, the same way you would write a normal class, but to inherit from a previous class, to inherit from parent, you put the parent class in brackets, just like this, dog, okay? Then, in the init function, in the constructor, we do the same thing, and we're going to want a name, right? We're going to want a name for our Labrador, but as you can see, we're not going to need a breed. We're not going to need the user to specify what breed the Labrador is because it's always going to be a Labrador. Okay, so in this init function, we're going to specify the values which we want the user to enter to create a Labrador. But because we're inheriting from another class, we need to also initialize that parent. Okay, I'll show you what I mean. Now, I told you earlier that this is also known as the super class, right? So what we do is we write super and we do open close brackets and then we do dot init. Now this runs the constructor of the parent class, okay? And we specify the name, which is the name that we got from the user, and then the breed is always going to be Labrador. So I'm going to specify that here. Let's spell it correctly. There we go. So just to recap, this is the constructor of the child class, okay? This is running the init function, the constructor of the parent class. And now this, running the constructor of the parent class, allows you to create this new child object based on the parent class, okay? So this will run the init function of the parent class. So anything that happens here will also happen in this child, okay? So in this child, the new favorite food will already be set. But let's say that we want to call some slightly different favorite foods. We can do that now. So if I create another one of the same name, so I'm just going to copy and paste this here. And we're going to choose from some slightly different one. Let's say Labradors don't like vegetables at all. I don't think any dogs like vegetables, to be honest. But let's put instead lamb for this, okay? Now, in this init function, we can also call this this method, okay, just like that. And now in this child class, it will also create its new favorite food. Okay, it will already have been set in this dog parent class, but in the child class, we also want to set from some slightly different options, right? So that's what we've done. Now, you might have seen from the last section that there are no private attributes or private methods in this parent class. And I've done that deliberately because private attributes cannot be inherited from a parent into a child class, right? So anything like if I had done underscore favorite food, because of how name mangling works, and name mangling sort of, I said it appends or prepends the name of the actual class. For example, this would be underscore dog underscore favorite food. This links it to the dog class. But if we were to reference it here, like for example, if we were to do self dot underscore favorite food, this doesn't actually exist because self in the child class refers to the Labrador. So what this would mean underscore Labrador underscore favorite food, which would not be the same as the dog one. Therefore, it's not been inherited. Okay. So we have to use public attributes when inheriting. But you can, if you want, create your own private attributes once you've initialized everything. That's perfectly fine. Just no attributes can be inherited. No private attributes can be inherited from the parent. And we can still use the same gets and set methods as normal. Let's give that a try now. Let's see. Let's create a Labrador object now. My Labrador equals Labrador. And we'll give him a name. Okay. Now let's try and get his favorite food now. So print get fav food. Oh no, my Labrador.get fav food. Just like that. Now just to make it super clear, let's create 3 completely different options from this, just to make sure that it's working, because of course beef and pork are common here. Let's say rabbit and what else do they like? Let's say cat. Okay. I hope dogs don't eat cats, but let's see. Okay. So let's give it a try now. As you can see, cat is one of the options here. So this method has been run, this get favorite food. This is an inherited method. It's been inherited from the parent, but it can still work with this child because it's been inherited, but this self.fav food is still accessible in the child class. So it was still able to print this out. As you can see, it printed out cat. Let's try setting something now. If I say, let's remove the print here. Say set favorite food. Let's try chips again, just to make sure that this is still working. Okay. As you can see, it says this is not a suitable food. Perfect. So that's how inheritance works in Python. Alright, so the final feature we're going to be looking at in this video is polymorphism. Okay, so polymorphism is a slightly more difficult one to explain than the other two, but it involves thinking of a common interface, or sort of the same interface for a class, but with aspects of the class doing different things depending on the values that you put into them. Okay, so let me give, this is best explained with an example, right? Let's say that we have a dog class once again, and in our child classes, right, like our Labrador class, let's say we have a Labrador class and a Bulldog class, just like this. Okay, so here we have a dog parent class, and then we have 2 child classes, Labrador and Bulldog. Okay, so we've created these classes now. Now we might think that every dog might bark a little bit differently, right? So let's create a different bark method for each different dog. Okay, so in our Labrador class, we're going to create the method bark. It's going to have the exact same identifier. Okay, bark. Instead, it's going to bark a bit differently, isn't it? Let's say woof, like that. Okay, so this is how the Labrador barks. Now let's try it in the Bulldog. We're going to give exactly the same name. Okay, but instead it's going to bark again differently. Woof, woof, woof. Okay, So as you can see, they bark differently. But now let's try creating two objects. So we're going to create my Labrador, Bob, and then we're going to create a Bulldog, Rob. Okay, now let's try making both of them bark. Okay, so we're going to do my Labrador dot bark, and then do the same thing with my Bulldog, just like that. Now, as you can see, they are using the same sort of interface, same method name, but the underlying activity, the underlying use is different. Okay, let's give it a try. As you can see, they both can use the same name, dot bark, but they both have different outputs. This is called method overriding, where you have a method with the same name, but it does different things. Now there is a second way of using polymorphism, and it's called method overloading. Now this is where the method can do different things depending on what values are passed into it. Okay, so let's say with this dog class, right, when we're initializing it, we can think, let's say the dog can have a favorite activity. It doesn't have to, but it can. Okay, so we can specify this parameter here, fav activity, but we can give it a default value of none. Okay, so this is its default value. Now, because it has a default value, it means when the user is creating an object, or when you're creating an object with it, you don't have to pass in this value. Okay, it's automatically set, but they can specify a value for this parameter. Okay, so let's start off with this now. We can, if the user specifies a value for this fav activity, it won't be equal to none, right? So we can say if fav activity is equal or not equal to none, just like this, then we can say let's do it a slightly different way. So let's say that every time, no matter what happens, even if the user doesn't specify what the activity is, we're going to say self.fav activity equals fav activity. Okay. Now, after it gives its greeting message, right? Well, let's say that it does if self.fav activity is not equal to none. That means that the user specified an activity. We can say print, and then we'll do the name of the dog, self.name, do an f string, self.name apostrophe s's favorite activity is, and then we'll do self.fav activity. Therefore, if the user specifies a value, then this will work. If not, then it doesn't matter. That means that the method can do different things depending on what the user specifies in the parameters. Let's give it a try then. So we'll do my dog1 equals dog. We'll call him Bob. He's going to be a Labrador. And his favorite activity, as you can see here, I don't actually have to specify it. It's already selected as none, right? So we're not going to specify anything. Now let's try my dog2. We're going to call him Rob. And he's also a Labrador. But this time we can specify his favorite activity if we want. Let's say sleeping. Okay. Let's give it a try then. So in our first one, it only said the greeting message. But in the second one, it said the greeting message and it said this part about the favorite activity because we specified it. But in the first one, even though we didn't specify it, nothing happened, right? So this is how you can use method overloading in Python. Alright, let's recap all the 3 different functions of classes now. So, inheritance is where you create child classes from a single parent class, and child classes will inherit the methods and attributes from the parent. And remember, private attributes cannot be inherited. Encapsulation is building a class into a single unit with private attributes and methods. These can't be directly accessed, remember, so they can only be accessed from outside the class by using public methods. And finally, polymorphism is where you use the same interface on the outside, but which may have different underlying uses depending on the class. For example, you can have method overriding, which is where you have a method with the same identifier in 2 different classes, which can have 2 different uses. Or you can have method overloading, which is where you change how the method behaves depending on the values that you pass into it. So that's going to be it for this video. I hope this has helped you understand a little bit more about all the different features of classes. If it helped you, please do leave a like down below and subscribe to the channel for more videos like this. Please do check out the rest of the series once you've mastered the basics of Python. I'll leave the playlist link down in the description. Thanks for watching, and I'll see you in the next video.